Hello everyone, thank you for coming. My name is Borja and I'm a build engineer at Twitter. We don't have a lot of time, so I'll just dive right in. At Twitter, most of our code lives in a big monorepo. And many years ago, we decided to unify the code for all of our services and infrastructure to a single repo called source. We haven't looked back more than a few times since. Up until now, we've been using a fairly in-house tool called Pants to build and test all of that code. However, as of earlier this year, we are migrating to Bazel as our tool of choice for that task. We believe that this particular migration implies interesting challenges that the community could learn from, and I hope by the end of this presentation you will think that as well. There are two main reasons for this migration. First and foremost, there's the user experience. Bazel promises speed and reliability, and our experiments and personal experience confirm that. By migrating to Bazel, our users will be able to tap into all of that effort that the Bazel team and rule writing community have put into making it rock solid. That leads me to the second reason that we want to migrate, which is the community. Our users face problems that are common to a lot of organizations in the Bazel ecosystem. And by becoming active members of the community, we will enable our users to take advantage of that infrastructure and effort, as well as help the community push forward on problems that matter to all of us, like remote execution. So, as we started our migration, what do we have to work with? Well, Source, Twitter's monorepo, has grown pretty big over the years, and it's not showing any signs of slowing down. It has 20 million lines of handwritten code, and roughly 10 times that in generated code. So it's definitely not something you want to compile on your laptop. Most of that code are backend microservices written in Scala, but we also have a fair amount of Python and Java, with some C, C++, Go, and Node.js sprinkled in for garnish. Almost 2,000 engineers work in Source daily. That's spread across backend, the frontend, and some machine learning. And those are our customers and the people who we want to make their lives easier. Up until now, we've used Pants to build and test code in Source. Pants is very similar to Bazel in many regards, including using build files to define your build configuration. It's a tool built for big multi-language monorepos, and it has currently about 20 active contributors. Let's see a brief introduction to the Pants model, just to see how similar it is to Bazel. Here we have the same target declared in Pants and Bazel. The syntax looks very similar, with the exception of some load statements and the name of some attributes like sources and depths. That seems pretty easy to migrate from one to the other, right? However, hidden in there are substantial differences between how Pants and Bazel see the world. For instance, in Pants, a target will implicitly have all of its transitive dependencies when being compiled. This means in the JVM world that it will have in its compiled class path the jars for all of its transitive dependencies. Bazel, in contrast, will not make those dependencies available unless they are explicitly exported. Even though we actively encourage users to explicitly export their dependencies, we don't enforce that. For third-party dependencies, Pants decides the exact versions of each dependency depending on the target being built in the command line. In JVM parlance, this means that it will resolve the transitive closure of the targets being built in the command line, whereas Bazel really wants to do a transitive closure resolve of the whole repo before even running. This leads to very interesting design trade-offs that we'll explore later. Finally, the last example is that Pants build files are just Python, which means that they have unfettered access to the file system, the Python standard library, and the network. And even though using this is actively discouraged, we find that users tend to use features that we allow them to use, whether we intend to put them there or not. It also allows users to declare functions inside build files, which is another point of friction with Bazel. These are just some of the model differences that we need to solve for this migration. We will see how we have designed the process itself to bridge these differences in a way that serves our users the best we can. From the very beginning, we have aimed to minimize friction for users. even at the expense of extra complexity for our team or extra time for the migration. This means the migration will be long, but hopefully our users shouldn't suffer from it at all. For a repo the size of source, this immediately discards any big bang style approaches where we suddenly change all the build files to be Bazel compatible. Even if we were able to pull off the rewrite of such massive amount of build files on the first try, the burden of 2,000 users asking questions about Bazel and learning to use it at the same time would definitely collapse our ability to give them the support they need, and it would lead to a subpar experience both for them and for us, which is not desirable. So, after some consideration, we decided to adopt a more gradual approach that allows us to progressively increase compatibility with Bazel in the repo, whilst maintaining pants compatibility so that a user will always have pants to fall back on. How do we do that? Well, we use something called the translation layer. The main idea behind the translation layer is that for each pants target type, we create a Bazel macro with the same name that translates the attributes to have the names Bazel expects. Here, for instance, we translate the sources attribute to srcs and translate the pants Scala library into a Scala library from rule Scala, the rule Scala rule set, which is imported from outside in the workspace. We then take those macros and load them in Prelude Bazel. That will make them available to Bazel at parse time so that Bazel is able to understand any pants build file without having to modify the build file. Taking a step back, here's the flow a user will follow when running Bazel in source and doing the migration. A user will tell Bazel to build a target, a pants target that they're comfortable and used to. Bazel will import the translation layer at load time. It will translate the pants target into Bazel rules using a combination of native rules, external rule sets, and some of our own internal rules. It will return the build graph in terms of understandable Bazel targets, and it will run it just as if it were any other Bazel run. This way, we can keep source compatible with both pants and Bazel at the same time. And when we achieve that, we can introduce teams to Bazel on a piecemeal basis as we get the capacity to give them the support they need. That way we can ensure a great experience for them. When every team is migrated to using Bazel in their day-to-day and they don't need to fall back on pants anymore, we can make progressive passes to remove the translation layer until eventually we are left with a pure Bazel experience. That sounds great, right? Well, it works really well for simple transformations, as we've seen. However, where things get complicated is here, in the ellipsis. The translation layer is not just a syntactic layer. It needs to bridge the fundamental models between the two tools. Here, in the ellipsis, is where we find solutions to all those footnotes, and it's here where most of the complexity of the layer lives. Here's also where we'll learn most of our lessons. We will see one example of such complexity later. But for now, this is the state of the migration. We are compatible with many targets in source. We are rapidly expanding to cover the remaining workflows and targets. And we have just completed successfully our first pilot, resulting in some users using Bazel in their day-to-day lives and being very happy with it. So, where do we go from here? Regarding the Bazel community, we are currently consuming a lot more than we are contributing back. Our interactions are mostly finding a rule set that does what we need it to do, that replicates the pants functionality, and then using that to build the translation layer around it. However, we hope that the lessons learned in this migration will help contribute back to the community as a whole, and that we can contribute to ongoing wide-reaching efforts such as remote execution and outlining when we are done with the migration. However, even during it, sometimes we need to slightly adjust some external rule set to fit our needs. And these times, we are adopting a strategy to upstream these changes by default. This means collaborating with the Bazel ecosystem to find a solution that fits everyone, and investing people's time and resources to make it happen. We've already contributed a few changes, but we hope to grow this relationship in the future as the migration finishes, and we get more bandwidth to work on these problems. Regarding the rest of the migration, our plan is to keep working out the model differences between Pans and Bazel, expanding the translation layer until we can start migrating teams to use Bazel every day. They will always have Pans to fall back on. For the end of this talk, I want to go through one such model difference and finally give you a taste of the sort of problems we're solving. So, let's talk about how we approach those design decisions. Whenever we're faced with a model difference between the two tools, we introduce some design tensions inevitably. We can try to replicate the Pans mode with Bazel, or we can plant a flag on the ground and move users to the Bazel way. And every decision has its trade-offs, and we need to consider them on a case-by-case basis. Replicating the Pans way is very comfortable for users. It means that they can treat Bazel roughly as a faster and more reliable Pans, but it places a heavier burden on the translation layer and on our team, which is something we're usually okay with, but we need to consider all the options. Moving users to the Bazel way, however, brings with it all of Bazel's guarantees and keeps the translation layer thin, but it means the users have a higher barrier to entry, and they have to learn new concepts in order to use the tool. We need to evaluate each of these cases separately, consider the trade-offs, and decide where in the spectrum we want to land. Our first pilot users have been invaluable in helping us navigate these decisions, because ultimately we want to make the best decisions for our users, so asking them is a very good idea. So let's take a look at one such problem. In source, some of our third-party JVM dependencies bring with them transitive dependencies. Some of those transitive dependencies overlap, and sometimes they are incompatible. At some point, we need to figure out which exact versions of transitive dependencies we need to include in our compilation, which is also called resolving the dependencies. In Pans, the exact versions of dependencies will depend on the set of targets you're building in a single command line. This means that you can technically have different versions of the same dependency even if they conflict living in your repository. However, you can never build them together. Bazel, however, expects to know every version of every dependency before even executing, for many reasons, including caching, security, and speed. This means that it really wants only one version of every dependency in a repository. They cannot coexist. So looking at this example, we see that both A and B transitively and invisibly depend on incompatible versions of transitive dep. In Pans, this would be fine as long as you never try to build A and B together in the same command line, which is often the case because often A and B are microservices that get built and deployed separately. In Bazel, however, this is a version conflict, and it's one that we need to solve before even trying to build A and B. In this example, whatever solution we end up settling in, it will implicitly affect a lot of other aspects of the development workflow. It will pose questions like how hard it is for a team to upgrade a dependency or introduce a new dependency. Is it their responsibility to upgrade the entire company? How do they handle version conflicts? How do they experience version conflicts? Where in the workflow does that fit? As we explored this problem, it became pretty clear that we needed to support multiple incompatible versions of different dependencies in source. There was no way around that. They were too ingrained in source, and there was no way we could settle on just one version of everything. So we landed pretty far into the Pans spectrum. Therefore, we are exploring different designs for allowing that to exist in Bazel with as little friction for the users as possible. We haven't really settled on a final design yet, but if anyone's interested, I'm more than happy to talk about these experiments after the talk. Whatever the final form of these experiments is, the things that we learn will benefit the entire community. As far as we know, this is a really tough problem that doesn't have a lot of prior art. We hope that we will exit this migration with many more interesting things like this one to contribute back. That's it for the technical part of the talk. Again, if you have any questions or thoughts, I would love to hear them in the Slack during sidebars. Before finishing this talk, I would like to acknowledge the effort of Daniel Wagner-Hall, Eddie Cole, and Stu Hood for conducting the initial experiments and settling the foundation for this migration. I would also like to thank Yi Cheng for his amazing contributions, which culminated in that amazing first pilot with very happy users that I talked about before. Lastly, I would also like to mention everyone in engineering effectiveness that has contributed to this migration. There are too many names to mention, but they all deserve praise. If any of these challenges sound interesting, please let us know. We are definitely looking for great people to join us in this effort. And that's it. Thank you for watching.